Repairing a Stuart 500 boiler cast iron mounting plate, testing the boiler and assembly. I would normally repair this type of damage by silver soldering a new shaped part in place. To repair this one, I used my MIG Welder. And here's how I repaired it. I found a piece of scrap steel angle, and when I cut it to shape on the bandsaw, it needs to be exactly the same size as the part that's broken off. Using my deep hole marker, which is a felt tip pen with a long point, I've copied the shape of the broken part onto the piece of steel angle. And even though I say so myself, it is quite a good fit. Although I didn't show this next sequence, using my MIG welder, I welded the part in place. My welder slightly damaged the edge of the part, but it's not important because I'm going to fill all this in using JB Weld. The main thing is the weld is very strong. I'll turn it over and show you underneath. This is when I ground away the excess. I really do need to carry on with the series MIG Welding for Beginners because I'm still not very good at it. I think I would be better at TIG welding because I don't like the speed at which the wire is always fed to the work, and I currently find using a MIG welder on very small parts to be quite difficult. It would appear that when you weld cast iron, what happens is the metal becomes extremely hard. The only way to clean it up is by grinding. This is JB Weld, the marine version of JB Weld. I bought this by accident. I'm sure it will do the job. JB Weld is a 2-pack epoxy mix, and one of them has steel particles in it. Here you see the 2 equal parts from the tubes on a piece of cardboard, and now after mixing this thoroughly, I apply it to the work. And I'm putting plenty on because once this is set in 24 hours, I'll be able to file it to shape. Here's a gratuitous shot of the JB Weld curing. And then, as if by magic, 24 hours later, I'm cleaning up the repair using a file. I started off by filing the JB Weld on the inside, followed by filing the outside. This was very simple to do, and in no time at all, the repair was starting to look quite good. I finished off the slot in the foot using a small needle file, which I also used to clean up this hole. I completed the job by using some emery cloth, and after a while I was quite pleased with the finish. Here's the before shot, and here is the after shot. It's a distinct improvement, and by the time it's painted, you won't even know it was broken. In the outer part of the workshop, I'm now going to use some Autopaint Northern high build etching primer. This is great stuff because it does 2 things. It sticks very well to the part that you're painting. Unlike some etching primers which you have to spray very thinly, you can spray this stuff just like an ordinary grey primer, which means that after you've painted the part you can rub it down without rubbing through to the bare metal. I've tried a few etching primers and this one I do find to be about the best. Bear in mind though that etching primers don't really stick well to brass. Paint generally speaking doesn't stick to brass well at all. But this etching primer sticks really well to this part, being made of cast iron with a bit of steel in it. The steel bit, of course, being the part that I welded in place. As usual, here's a shot of the paint drying for those of you who like to watch things like that, followed by another quick look at the can of etching primer. Here's a flashback to the state of the boiler when I received it. One of the boiler bushes had been drilled out and rethreaded with a thread I've never seen before, which was stripped anyway. This clip shows me removing what was left of the old boiler bush, and here I'm silver soldering in a brand new bush. After I'd done this job, I let the boiler cool thoroughly and then put it in the acid bath overnight. I was simultaneously working on 2 500 boilers, and here they are coming out of the acid bath. After doing any repair work on a boiler, I would always perform a hydraulic test. And here is the test to make sure that my bush doesn't leak. A leaky bush would not be a good thing. I've cleaned away all of the water from the bench and immediate area, and here I've applied hydraulic pressure to 120 pounds per square inch, which is twice working pressure. I held this pressure for about half an hour and there's no sign of any leaks, which is a good thing because it means my repair was successful. The test is over and I'm dropping the hydraulic pressure by carefully undoing this plug. Very slowly. When I finally take it out at the end of the test, the last bit of pressure, about 10 psi, did this. You can imagine how much water would have issued forth had I have done this at a higher pressure. The 500 series and the 501 are held together in a different way to the 504s. They use 4 threaded rods. Simple enough but quite fiddly to assemble. I'm really happy now. Because the boilers are assembled, they are taking up far less space on the shelf. What you see here from left to right are 2 501 boilers, 2 500 boilers and 2 504s. I also assembled a 504 boiler so I could plan the steam plant layout. The 504 boiler that I will be using for the steam plant is the brand new one at the right hand side. And that is it for this video. Stay healthy, thanks for watching, and I hope you found it useful. Please take the time to visit my main Steam Models website and click on the section of the website that says Video Playlists. And by doing that, you can find other videos that you may like to watch. And by using the playlists, you can actually watch the videos back to back.